Hi, in this lecture I will focus on the DTFT, IDTFT and their problems relating to convolution as well. In the previous lecture we have seen that we have two kinds of signal, and we have, for the continuous time signal, these two mathematical models. One is the Fourier series and other is the Fourier transform for the conversion of time domain signal which are continuous into frequency domain signals as demonstrated by the figures. And also for the discrete case we have TFT and DTFT for the transformation of discrete time signal into frequency domain as demonstrated by the diagram. Now we will see about DTFT. We have xn, which is indicating the discrete time signal, and xt, the continuous time signal, and the discrete time signal can be converted into continuous time signal indicated by W, which is the continuous frequency indicator, with the help of DTFT, and we can also elaborate it XW as XEJW. And we, when do that conversion from the continuous frequency into the discrete time, for that we use the inverse discrete time Fourier transformation. So we have a formula for the conversion of discrete time signal into continuous frequency with the help of the DTFT, which is this formula, which is minus infinity to plus infinity summation into xn, which is the discrete time signal in relation with the exponential term, and the output will be a continuous frequency signal. For the IDTFT, for the conversion of the continuous frequency into a discrete time, we use this kind of mathematical model, which is 1 by 2 pi into integral, which is indicating the frequency limits of this continuous frequency signal in relation with the exponential operator, and dw coming in relation with the integral. So by this formula we can do the conversion of this frequency signal, continuous frequency signal, into discrete time signal with the help of IDTFT. So to find the magnitude and phase of the signal with the help of DTFT, we can do it in two ways. We can either do the calculation in the polar form as indicated over here, the magnitude represented by the mod and the angle by represented by this kind of operator and coming the angle afterwards. And we can also represent the magnitude and phase of any signal in the rectangular Cartesian form as well, where xw is equal to real value plus j into imaginary values. And we can also transform this Cartesian form into that polar form by using these two relations for the magnitude as well as phase calculation, and by these relations we can do the transformation of any Cartesian form into polar form as well. DTFT is used theoretically for the analysis of the signals relating to speech processing, image processing, signal and video processing. Now we will see some formulas or some problems relating to DTFT. If we have this kind of signal which is having this kind of conditions, and we have to find the DTFT, for which we are converting it xn into xw, then we will be using the formula of the DTFT, putting that value and obeying its conditions. We will be opening this summation limit, we will getting this kind of expression, and putting the values as per conditions mentioned over here, we will get this kind of response. In the second problem, we have to uh, have to do the conversion of this xn signal with these kind of conditions, and we have to analyze the xw. And first of all we have to simplify this expression of mod over here. So this mod is indicating the same response on the both sides, and we can firstly we can do its simplification. We have two values of xn. One is an, which is obeying this condition, and other is a minus n, which is obeying this condition. So we have to calculate the xw of both these values, and once we get the xw of both these values, we can add to get the overall response. So we will do what? We first take this value and we put it in the formula of the DTFT over here, and we take the power common n, and then we have this kind of simplification which is already available to us, and we can apply it on this expression to get this answer. Then we use this kind of xn, and we have to calculate the xw, and this is this value, and we putting it in the formula of the DTFT, and we reversing the limit over here, and we changing the sign, and this operation on the summation will change the scenario inwards, which will be creating the powers of both these from negative to positive. And we have to add and subtract 1 over here because we need to convert this expression into this expression so that we can use this relation and we can simplify our problem. Otherwise it will be a very complex kind of analysis over here, and we will getting this xw. So we have calculated two xw's. One is x1w over here and other is x2w over here, and we do the addition of both to get the overall xw. Now we have to have a convolution uh, operator. You already know that convolution is the estimation of the output from the input and impulse response of the system. So we can do the convolution in two ways. Either we can do it in the time domain as well as in the frequency domain. So we have these two convolution formulas. In the time domain it is this kind of convolution calculation, and in the frequency domain it is multiplication. With the help of a multiplication we can do the convolution. So we have these two signals. One of them we can assume that it is the input of the system and other as the impulse response of the system, and both these have the same values, which is indicated by these kind of sample values. Downward above arrow is showing the 0 value, and this is the past and this is the future values. And we have to do the calculation of the convolution by using the DTFT method, because we have various methods. We have the DFT method, we have the DTFT method, we have the ZT method, we have the direct method for the calculation of the convolution. And in this problem we will definitely do the calculation of these frequency expressions with the help of DTFT, and afterward we do their calculation, we can multiply them. So we have these indicating the same values. We can do the calculation of one, then definitely the second one we can calculate it as well. So putting the formula in the DTFT formula, and in the DTFT formula we have put the -1 to +1 and putting that value, opening the summation to get this kind of expression, because we have both these equal, so their xw will be equal to both, and we can do the calculation of the convolution by multiplying these two values. So we will multiply these two values, we get this value, and after that we have to inverse transform back into the original time domain value. And for that we already have this formula of the DTFT, which is converting those time values into frequency values. So by observing this formula, and n is positive for E negative and n is negative for E positive, so we have to analyze this formula, we have to see that expression, and we can convert that into inverse. We can, by observing, we can do its conversion from xw, because these are the xw values, and we can do by observing their conversion into the xn values, and we are putting their coefficients over here because E0 is indicating the zero level value, so the coefficient is coming over here. The negative values are indicating the positive one and this positive 2 value, and we are putting their coefficients over here, and similarly the negative 1 or negative 2 values, we are putting their coefficients over here, and we get what we want. Now we have to do the calculation of the IDTFT, and we have this frequency value. We want to get HN value from that. So whenever we have any problem, we see that we have an easier way to solve that problem just by observing it, or if we have no way to solve that problem, then we will be definitely using the inverse DFT formula over there, and from that we will be definitely getting the value which we want. So this is the value, and we have this relation by which we can transform any trigonometric expression into exponential expression. So we have done it for the above, and then we have, with the same way, we have analyzed this formula, and we have replaced their coefficients, and we have transformed the xw value into the xn value just like in the above numerical. So we can also represent it, this hn value, in the form of conditions over here. We have another problem where we have xw with conditions mentioned over here. We want to transform it into xn by using the IDTFT value formula, and we have to plot it as well. So we have the IDTFT formula we have used, and we have put that value over here. We have not used the simple way as we have used in the previous two numericals for the transformation of xw into xn or hw into hn, because we have this for expression which is already in a complicated form, and it cannot be transformed into xn without the use of this formula. So we have put that value over here, we have put the limits over here, we have done the simplification, we have done the definite integration, and then uh, till here we get the value, and then we have to put the -1, 0 and 1 values over here, and we can get their plotting as well. And then we have another numerical in which we have this hw value with these conditions. We want to transform it into hn. We will be using the IDTFT formula, putting this value with the conditions over here, doing the definite integration, and then we have till this expression we will be putting the value of -1, 0 or 1 in the n values, and we can plot that expression as well. Thank you very much.